Okay, we're set to go. Does everyone say hi, Stuart? 1, 2, 3. Okay, Stuart, we love you. And so hopefully this is picking up. If it doesn't, then I guess this is all in vain. But we'll give it our best shot. But we were going to pick up on an example too. It says, yeah, all right, okay, Comedy Central. Can you say that you love what? That you love him? No. All right, we'll wait. Okay, I think he's more concerned about getting his math done. Let's just focus on that. Okay. All right. So it says a particle moves according to a law of motion. S is equal to F of t for time greater than or equal to 0, where t is measured in seconds and s in feet. S of t is equal to 4t minus 10 over t squared plus 3. This is a little bit more challenging of a problem, but there's some nice shortcuts to it that can help us out. So first of all, if I want to find the velocity, this is S of t. S of t stands for what? The starts with a P, rhymes with position. Position. So this is the position function. You want the velocity function. How do we find the velocity function? Take the derivative. I need more space in this, so I'm going to scroll down here. And looks like we have 4t minus 10 over t squared plus 3. So I have 4t minus 10 over t squared plus 3. Excellent. So how am I going to take the derivative of that? What rule do I have to use? The quotient rule. And the quotient rule says I take the derivative of the top, which is 4, times the bottom left alone, which is t squared plus 3, minus the derivative of the bottom, which is 2t, times the top left alone, which is 4t minus 10, all over the bottom squared, which is t squared plus 3 quantity squared. Okay, well, I don't think we need to, try to reduce it necessarily, but let's at least try to make this a little bit more workable. Let's try to combine like terms on the top. Can we at least do that? Okay, so we get 4t squared plus 12 minus 8t squared plus 20t all over t squared plus 3 quantity squared equals, what do I get when I combine like terms? Negative 4t squared plus 20t plus 12 divided by t squared plus 3 quantity squared. Okay, so that's really my derivative. That's something that I can make use of. So we'll what? Everybody see how we got that derivative? Okay, so we can leave that aside. Yeah. Oh, is that a fat joke? Okay, thank you. All right. Maybe a little one. Track season cannot come soon enough. I would agree. Yeah. Okay, so Stuart, that would be Chelsea, who is detaining us for that period of time. So we go negative 4t squared plus 20t plus 12 divided by t squared plus 3 quantity squared. I should mention I haven't actually worked this problem out yet, so hopefully we do it right. Velocity of t is equal to that. So what's the velocity after 3 seconds? What would I do? Plug in 3. Okay? And So we'll do some work here. V of 3 is equal to negative 4 times 9 would be negative 36 plus 60 plus 12 divided by 144. God, who made up this problem? Negative 36 plus 60 plus 12. 36 divided by 144. Who made up that problem? 1/4. So V of 3 is equal to 1/4. What does that mean? It's a derivative. It better have rate attached to it. What rate of change? Okay. So what is change? What? Feet per second. That's a rate. That's a rate. 1/4 feet per second. Not moving very fast, huh? Oh boy. It says, when is the particle at rest? What does that mean? That means when the derivative is equal to 0. So, hey, no. So this is where you're going to learn something that's going to help you a lot. Watch this. So when is the particle at rest? Well, we'll solve V of t is equal to 0. Now, if we look at our derivative, the derivative looks really, really, really bad to work with this situation. But it's really not that bad. Okay, I want you to look at the bottom. I want you to look at the bottom. What do we know about the bottom? It's always positive. Why is it always positive? Because it's being squared. And even the original function, it's always positive on the bottom because t squared is positive. Has to be positive. You square something, you get a positive number. Add 3 to it, then square it. So this is positive on the bottom. Now, can the denominator be equal to 0? Can we have 0 in the denominator? No. So really all we want to find is, tell me if I'm true or false here, if the numerator is equal to 0, the entire thing's equal to 0. Yeah. So instead of setting this whole thing equals 0, I could just look at the numerator. And that will make things a lot easier. So let's set the numerator equal to 0. Negative 4t squared plus 20t plus 12 equals 0. What do you want to factor out? A negative 4. So 0 equals negative 4 times t squared minus 5t minus 3. Okay, so I want to solve that piece right there. Does that factor? So I use the quadratic formula, which if you have it on your calculator, go ahead and use it. I don't have the, would you, if I print off the quadratic formula for your calculators, will you put it in? Okay, all right, I'll give you some of that stuff. I'll work on that. But let's do this piece right here. We'll use a quadratic formula. Not too bad. Negative b plus or minus square root of b squared, which is 25, minus 4 times 1 times negative 3 all over twice my a value. Minus 4 times a times c. Minus 4ac. So I get 5 plus or minus the square root of, let's see, negative 4 times 1 times negative 3 is negative, or positive 12. So 25 plus 12 is 37 divided by 2. So I'm going to get 2 results there, and I can figure these out. If I go 5 plus the square root of 37, divide that by 2. So it looks like 5.54. So 5.54 would be 1, and if we go, let's see, 5 minus square root of 37 divided by 2, I get negative 0.54. Can I have negative 0.54 seconds? No, because my domain stipulates that I only have positive time here. So we get rid of that. So we know 5.54 seconds. So again, notice the trick. We set the numerator equal to 0 because the denominator we knew something about it was always positive. Wasn't a problem. 5.54 seconds is when it's equal to 0. So time equals 5.54. When is the particle moving in the positive direction? When the derivative is positive. So we want to solve for where v of t is greater than or equal to 0. In this situation, isn't that the same when the top is greater than or equal to 0? I mean, if we find out where the top is positive, the bottom's always positive, right? So I just really want to find out where the top is positive. Let's use our calculator for this. We'll save some time. So I type in the top negative 4x squared plus 20x plus 12. Again, I want to find where the derivative is positive. Well, the derivative is going to be positive wherever that thing's positive. So let's find it. We graph it. I'll zoom standard. Okay, so it looks like the graph is positive from here to there, right? What is that spot right there? That's that 5.54. So it looks like the derivative is positive from 0 to 5.54. So that's our interval. When is the particle moving in the positive direction? From 0 to 5.54. Well, if we know where the top is positive, then the bottom is going to be positive as well there. So we're okay. Question? Well, technically at time 0 we would include, because of this domain piece. So since t is greater than or equal to 0, we could say we could include that. Good question. So I did not include 5.54 though, because technically at that time it's equal to 0. Ooh, find the total distance. This was a hard one, wasn't it? Okay, so I'm going to get rid of some of this stuff here. And I'm going to go back to my calculator, and I'm going to use that to give me some help. I'm going to type in my original problem, which is 4x minus 10 divided by, what, t squared plus 3? So x squared plus 3. And I'm not going to graph it, but I'm going to use that to calculate values for me. Okay? So I want to figure out, hey, don't do that. Whoa, where'd you all go? No! We are very sorry, Stuart. Go away. There you are. Thank you. Okay, we're back. Okay, so we're going to use our calculator, but we got to figure out where this thing starts. So, you know, where does it start? So let's try to figure that out. I'm going to go to my table, and I'm going to have it ask me values. And for a if the x value is 0, so at 0 time, my position is negative 3.33. So the position of the particle at time 0 is negative 3.33. Does it start by heading in the positive direction or negative direction? Positive. We found that the particle was moving in the positive direction from 0 to 5.54. So it's moving in the positive direction right away. So I need to find out where it's at what time? At 5.54. Because it's going to change direction at that time. So it starts here, and it takes off moving in that direction. So I'm going to see here at 5.54, I get 0.36. Oh, yeah. So it moved from here to 0.36. Now, what's the particle going to do after that? It's going to move back in the opposite direction because we know it's negative after that. So it's going to move back in the opposite direction. And so I have to figure out where it's at what time now? At time 8. So again, I go to my calculator, I plug in time 8, and I get 0.328. So we'll answer some of these questions, but let me finish with just the total distance, and then we'll get to the questions. The particle started at negative 3.3. Oh, didn't move very far, did it? So the particle went all the way over to 0.36, and then it came back to 0.328. So it hasn't moved very far. However, whatever concept that is for us in terms of length, maybe it truly is really far. But at 0, it started there. At 5.5 seconds, it got to 0.36. And then at 8 seconds, it came back to 0.328. So how would I figure out the total amount of distance? So that distance is 3.33. And it moves another 0.36. And then it moves back. Let's see. We would have 0.36 minus 0.328, and we get like 0.032. So then it moves back 0.032. If I add all of those up, 3.722. Bada bing. Yes. Thank you so much, Stuart, for paying attention. Hopefully it all makes sense. Everybody will say goodbye now. Ready? 1, 2, 3. Later, bud.